Okay, consider the following two sets. Natural numbers less than 20 divisible by 3, and natural numbers less than 20 divisible by 5. Let's get those down. Less than 20 and divisible by 3 would be 3, 6, 9, 12, 15, 18. End of list. I didn't put 0 because they said natural numbers, not whole numbers today. And natural numbers divisible by 5 would be 5, 10, 15, and 20 is not less than 20, so that's all we get for that list. Now, explain why the set of natural numbers less than 20 is a suitable universal set. Universal set is a big group that contains all the things you want to talk about. If you're talking about people, your universal set might be all the people in the world, or all the people in your class, or all the people who have ever lived. It kind of depends what the rest of the conversation is about. But in this case, we're talking about natural numbers less than 20. Both of these statements are about natural numbers less than 20, so we might as well start with that as our main group. Then we can get into, okay, which of you guys are divisible by 3, which of you are divisible by 5. There we are. I'm just going to make these bold to make it a little easier to read. Good. Okay. So it's a suitable universal set because it contains all of these numbers. A and B both agree that they want to talk about natural numbers less than 20, so that's a good place to jump off. List the elements of the following sets. Okay, well, set A, already listed it up here, but what the heck, we'll write it again. The set A is 3, 6, 9, 12, 15, 18. Now, A prime, also written not A or sometimes A with a bar over top, means the negation of A, all the things that are not in this set. So that would mean all the numbers that belong to our universal set that aren't in here. Everybody who's against these guys. So that would mean 1, 2, not 3, he's in this set, 4, 5, not 6, 7, 8, not 9, 10, 11, not 12, 13, 14, not 15, 16, 17, not 18, 19, end of list. That's all the numbers that are less than 20. Something to watch for, if you ever combine a set and its negation set like this, you should end up with the universal set. You should end up with every number being either in this set or in its opposite. So with people, if you did like people with blue eyes and people without blue eyes, between those two groups, you've got absolutely everything covered. There's a, I'll tell you at the end. There's a set, if they want set B, we know that one's just 5, 10, 15. Write a description of the elements of the complement of set B in words. The complement, or the negation of set B, would be natural numbers less than 20 that are not divisible by 5. So, natural numbers less than 20 that are not divisible by 5. If you were thinking that the complement of this should be like non-natural numbers or numbers that are not natural and that are not less than 20, that's a good idea, except remember our universal set. We've already narrowed ourselves down to saying the only numbers that exist in our world right now are natural numbers less than 20. So you're stuck with this. If you want to be in this conversation, then you've got to restrict yourself to natural numbers less than 20. The only part that's negatable is this, the divisible by 5. So you have numbers that divide by 5 and numbers that don't. Now, let's see what we get here. Set C is natural numbers less than 20 that are multiples of 6. So that would be 6, 12, 18, end of list. State whether the following are true or false. Okay, so this symbol means belongs to, or in logic, this literally means is a subset of. So some subsets are things like boys are a subset of children. Means every boy also belongs to this other group. Girls are also a subset of children. And children are a subset of people. And Avengers are a subset of superheroes, and so on. It just means every member of this small group also belongs to this bigger group. So here they're saying every member of set C, here it is, also belongs to set A. 3, 6, 9, 12, 15, 18. Is that true? Let's see. 6. Yep. 12. Yep. 18. Yep. So, yes. Multiples of 6 are a subset of multiples of 3. In other words, if you are divisible by 6, you're also divisible by 3. And I suppose that makes sense. Now, we have just the opposite of that. This is saying set C is not a subset of B. That means there are some members in this group that don't belong to group B as well. 6 is not part of group B, so right off the bat we know this one's true. That's saying not everyone who's in this group is a member of this group. For the not a subset, you get things like men is not a subset of fathers. Not everyone who's an adult male is a dad. You could do it the other way and say every dad is an adult male. That one would make sense, but not the other way around. And finally, oh, now they're getting tricky. Now we have negations of these. Now, not A is a subset of not C. I can't see this one without making a list, so let's get that happening. Not A. Oh, well, lucky us, we have it already. Here's not A. This is all the non-members, all the people who don't belong to group A. And not C, here's C, which contains 1, 2, 3, 4, 5, not 6, 7, 8, 9, 10, 11, not 12, 13, 14, 15, 16, 17, not 18, 19, and we're talking numbers less than 20, so 20 doesn't get to be on the list. So what we're checking is, do all the members of not A or A prime belong to the C prime group as well? So this may take a bit. 1, check. 2, check. 4, check. 5, check. 7, check. 8, check. 10, check. 11, check. What did I write there? Yeah, that's 11, and then I bumped the scroll bar, made a bit of a mistake, but that's just 11. 13, check. 14, check. 16, check. 17, check. 19, check. So yes, A prime is a subset of C prime. Every number that is not divisible by 3 is also not divisible by 6. So that one's all right. Last thing, this is not part of the course, but I thought it was funny. I was talking up here about how you have, if you take a set and you combine it with the negation of that set or that set's complement, then you get the universal set. These two sets together contain every number that there is. There's a book that came out a while ago in the early 70s that was called What They Don't Teach You at Harvard Business School. And so this book came out, which said, it's supposed to be all the inside secrets that you learn when you're out in the business world, but that they don't teach you in school. And it turns out there's another book out there which is called this. And the joke was that between these two books combined contain all the knowledge in the universe, because this one contains the things they teach you, this one contains the things they don't. So this is like H and H prime. Between the two of them, they're the universal set, so they contain everything you could possibly know. Probably not true, but it's the kind of silliness you can get into with set theory. Now you know a nerdy logic joke.